Question number 7 gives us a boat leaving a dock at 1400 hours and traveling due south at a speed of 20 kilometers. Another boat is heading due east at 15 kilometers and reaches that dock at 1500 hours. At what time were the boats closest together? So, first off, 1400 hours is just military time. That means 2 p.m. And 1500 hours means 3 p.m. Don't get thrown off by those parts. It says it's traveling due south at 20 kilometers per hour. So, we have a boat traveling this way and another boat traveling this way. And we want to know when they are closest to one another. So we want to minimize the distance between them. To do that, we need coordinates. So what I know is we're going to call this the origin. If this is the origin, this boat traveling south starts at the point 0, 0, and the y coordinate is going to change over time. It's going to change by 20 kilometers every hour. So in 1 hour, it'll be down at 0, -20. In 2 hours, it'll be down at 0, -40, and so on. So wherever it is when we're looking at it, it's going to be at the point 0 because it stays on the 0 for x, and -20 times however long it's been traveling south. The second point works the same way, but it starts out here at a point of -15, 0. And the reason I know it's at -15 is it takes it 1 hour from 2 p.m. to 3 p.m. to reach the dock. So wherever it's located, somewhere in here, is going to be located at -15, and the y or the x coordinate increases by 15 per hour, and the y coordinate is still 0. So I have two coordinates now. I can find the distance between them. The distance formula is the square root of x minus x, so that would be 0 minus 15 or plus 15t, so 0 minus 15 this one. So that'll be 15 minus 15t squared. And for the y coordinates, 0 minus -20t, so 20t squared. And that's going to become my distance formula. That's going to be the thing we try and optimize. So before we can do that, it's in one variable, but we need to simplify it. So I'm going to square that down. What that's going to turn into is 400t squared plus another 225t squared from this. So that'll turn into 625t squared. And then everything else will come from this part. 15 times 15 is 225 doubled, becomes minus 450t. And then plus 225. So that's going to be my function. Now, as we talked about in an earlier problem, when you optimize a radical, you only have to optimize the inside. So my function is just going to be this part on the inside. So now that we have our function, the rest of this tends to go pretty easily. The derivative is just the derivative of this, which would be 1250t minus 450. So to do our critical values, we set that equal to 0. So to do our critical values, 1250t equals 450. Dividing that out, t turns out to equal 9/25 when you reduce, or if you want to use the calculator, 0.36. So now we need to do two things: answer the question and go ahead and figure out, is it actually the minimum or the maximum we were hoping for? So we wanted them to be closest together, so we were trying to minimize. So we'll do the second derivative. The second derivative is simply going to be 1250, which is greater than 0 no matter what, which is concave up no matter what, which means our critical value is a minimum. Now, the only other thing we need to figure out is what's the answer to the actual question. At what time were the two boats closest together? Well, that's when t equals 0.36. Well, if I multiply that by 60, that'll tell me how many minutes that is, because 0.36 is in hours. 0.36 times 60 is approximately 21.6 minutes. So what that means is it's going to be closest to the other boat at 2 and 21 more minutes. So at 2:21, those boats were closest together.